A huge thanks to my Patreon supporters for making this episode possible. Count! Video! Today, a rather scary looking question from the Christmas edition of the International Gamma Mathematics Olympiad. What? You never heard of the International Gamma Mathematics Olympiad? Well, do not fear. I'm going to tell you more at the end of the video about the specifics, but hear me out before we get started with the main question. This right here is a free of charge online mathematics competition, and the registration is going to end on the 21st of May. You can still register and try your luck. The first round is also going to start on the weekend, so why not make sure to try it out by checking out the link down in the description. It's completely free of charge, and everyone who wishes to try out a bit of problem solving on the weekend can participate there. So definitely make sure to check it out. As mentioned before, more specifics at the end of the video, but just for your information. Now, we are going to let f and g be real-valued functions, and we want to let x and a, so the inputs in f and g, to be element of the real numbers, since they are real-valued functions. Also, we have two positive constants, which can also be 0, s and m, where f and g satisfy for all their inputs those two conditions, namely that if we add two transitions basically in f together, one to the left and one to the right, we are going to get that this is equal to 2 times of f of x times g of a divided by s. That's a mouthful. Also, the second condition is that the absolute value of f is always less or equal to our positive constant m. Now, what we need to prove in our question is that if f, the absolute value of f, is not identically equal to 0 and it attains a maximum value, then the absolute value of g of a must always be less or equal to s for all of our real inputs in g. Yeah, does look rather scary, but it's actually rather doable. And now we are going to dive right in, and I hope you're going to enjoy the video. Now, let's formulate this a little bit more. So we have an if statement, meaning it's an implication. So we have some form of implication. Now, what does the left-hand side of the implication say? Well, if f, or rather the absolute value of f, is not identically equal to 0, and if f has a maximum value, or rather the absolute value of f, and the absolute value of f attains a maximum, then this does imply that, this is the thing that we need to prove, that the absolute value of g of a is less or equal to the positive constant s. For all inputs a out of real numbers and s out of the positive real numbers. Now, why not let's go ahead and get started. I mean, we also have a few conditions given that we can make use of. At first, what we're going to do is we're going to talk about what it means for the absolute value of f to attain a maximum. Well, it attains a maximum, namely, if we plug a certain number into our f, or the absolute value of f, let's call it x naught. This right here is going to be our maximum value. It could be some kind of number, okay? For example, if we take this function, for example here, it's a 4th degree polynomial. This function attains a maximum exactly at this point. Yeah, and we are going to call the x value for the maximum x naught. Now, also the absolute value of f is not identically equal to 0, meaning the same thing holds for our maximum. This right here is most definitely not equal to 0, because f, the absolute value of it, is for all values not equal to 0 identically. Now, next thing we are going to do is we are going to take a look at the conditions here. Namely, why not plug, for example, our maximum value, our x naught, into this equation that we got right here. Meaning, if we were to plug this in, then we are going to get that f of x naught plus a plus f of x naught minus a is equal to. Now, what we're going to get is 2 times f of x naught times g of a divided by s. Now, there's an absolute value given, so why not apply the absolute value to both sides? Let's apply the absolute value to both sides. And we can actually break this up a tiny bit. I mean, s is a positive constant, so the absolute value of 1 over s is just 1 over s. 2 is also positive. Also, the absolute value of f times g is the same as the absolute value of f times the absolute value of g. So let's break this up at first. So that's equivalent to saying we are going to have 2 divided by s, absolute value of f of x naught, and then absolute value of g of a is equal to the absolute value of f of something plus f of another something. If you see something like this, the addition of things inside of an absolute value, this actually screams for the triangle inequality. Long story short, if we have the absolute value of x plus y, then this right here is always going to be less or equal to the absolute value of x plus the absolute value of y. This holds in each and every ordered field. What this just means is that direct paths are shorter, less or equal, than detours. Yeah, this is all that the triangle inequality actually states. Meaning we can make use of triangle inequality here, since this part right here is equal to the absolute value of blah 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 plus blah blah blah. All of this right here is less or equal to the absolute value of f of x naught plus a plus the absolute value of f of x naught minus a. Now, we can actually go a bit further. A cool thing about f of x naught is that this right here is, or at least f of x naught in and of itself, the maximum value. Now, what happens if we stray away from the from the maximum value by a little number a? So if we go a bit to the right, so plus a, what this means is, since this is the maximum, everything next to it is going to be strictly decreasing. Meaning, for example, this part is going to be here. Same for negative a. Meaning, what we got here is actually less than f of x naught. This is where the maximum value comes in. Less or equal to f of x naught. And this right here is also less or equal to f of x naught. Meaning, this right hand side that we got right here is also less or equal to the absolute value of f of x naught plus the absolute value of f of x naught. Well, this is curious. I mean, this is just 2 times the absolute value of f of x naught. And now we can go ahead and cancel a bit of stuff out. I mean, we got 2 on both sides here. Also, the absolute value of f for all inputs is not identically equal to 0, meaning we can divide both sides by it, and since the absolute value of something is going to spit out a positive number, it also doesn't change the order relation. This is, by the way, a reference to one of my last videos where I did some really stupid mistake in the casework, meaning what we're going to end up with is that the absolute value of g of a divided by s is less or equal to, if we cancel all of this stuff out multiplicatively, it's just going to give us 1. And if we now multiply both sides by s, under the condition that it's not equal to 0, maybe I should put this right here out of the condition. I just wrote it out, but it probably means that positive means in the sense not equal to 0. But under the condition that s is not equal to 0, we are going to get the thing which is desired, that the absolute value of g of a is less or equal to s. Also, s is positive, meaning multiplying both sides by it doesn't change the order relation, and hence we can consider this statement to be proved. And that was a fun little question, but where this came from, we got more, namely on the International Gamma Mathematics Olympiad. The International Gamma Mathematics Olympiad is basically an online mathematics competition in which people from all walks of life can participate to gain the best possible mathematical problem-solving experience completely free of cost. You can register and it won't cost you nothing. And this competition has been organized by an independent party, namely Daily Math over on Instagram. He has about 300k followers, something of that sort. His real name is Hamza. I think he already published some kind of book, I don't really know for certain. But what I know is that I think it's pretty cool that he's organizing a free mathematics Olympiad for everyone to participate in. Yeah, it's a cool thing to bring the mathematics community together, and you should most definitely participate. 21st of May, registration stop, and this is also the first day where the competition is going to start. So definitely make sure to check it out, and you can't really support the channel this way, but you can support your brain by trying it out, by trying your best, and maybe you can also win this competition. So yeah, make sure to try it out, and I thank you guys for watching it. And if you did enjoy this video, then why not subscribe to the channel. Also don't forget to check out Flammy's Wood, my channel where I play with my wood at all times. And up until next video, I wish you guys a flammable day. Ciao!